Data structures, dun dun dun. Just kidding, but a lot of people hate data structures, and we're gonna give you just a little tiny bit that you need to know for this course. I'm gonna give her this Invisalign. All right, much better. So let's set the stage here. In a previous video, we talked about how there are two main concepts or parts to programming. There's the remembering things portion of the program, and then there's the taking logical actions on those things that you're remembering, that information. We went further by explaining that we can get our program to remember information by storing them in something called variables. Does this look familiar? If none of that sounds familiar, please go back and watch those videos. This is a course for network engineers. Well, if you noticed from our variables video previously, we were using variables to store a singular piece of information, like an IP address. But what happens if you need to keep track of, let's say, 50 IP addresses, or just a lot more information in general? This means that we're going to need a better way to organize and retrieve our information in whatever program we're writing, and we're going to do that using something called data structures. Now, again, if you've been in tech, you might have heard of data structures as these scary, complicated things, and data structures can be very complex. But what we need to know is that data structures are kind of on a spectrum of much simpler to much more complex, and the vast majority of us, even as developers, are not going to use a lot of highly complex data structures day to day. It depends on your job and the kinds of things you build, but anybody who is going to program is going to use some of the less complex data structures that exist, and they're simple enough that I can explain them to you in one video. So again, don't be scared. It's not going to have you like doing math or I don't know, whatever else you might be worried about. Not only are we going to cover some data structures that are on the less complex side that I know that you can master, I've actually boiled it down to 3 different data structures that I think are going to give you a lot that you can build as a network engineer, and maybe you don't even really touch a lot of other data structures. This could be it for you. It depends on your journey. And those data structures are going to be a set, a list, and a dictionary. Again, some of this might seem familiar from video number 1 in the series, where we briefly touched on data structures just to talk about some of how developers have to think or how coders have to think when writing programs. For each of these examples, we're going to talk about what they are, when you might implement them, and how to do things with them. And we're going to use hands-on examples as always. And before we dive into our developer environment, if you've been watching this coding course and you've been enjoying it, please do me a favor and hit the subscribe button, because it helps me know what you like and helps support the channel for me to make videos in the future. Let's get to it. All right, finishing up this video on another day. I can't say that I'm feeling my best, but I'm gonna try my best for you guys. We show up for things that we care about, right? You're showing up to this course with everything that you've got going on and your hopes and desires, and I similarly care a lot about getting this information out there and about your success. So after all, as I get closer to my due date, I mean, who knows how easily I'm gonna be able to teach, so I'm really trying to make the most of this. So anywho, we're gonna talk about the set and the list first, because in some ways they're very similar. I've got our same file pulled open from last time, the last video. We have 2 basically functions or 2 logical things happening in this program right now that we're gonna build off of for our data structures examples. One is that we're adding the days uptime for 2 switches. Again, these are not necessarily the most useful examples, but we doing what we doing. And then we've been working with our firewall logic a lot. So we're not gonna work on the show IPS events logic, just because I think there's a lot more intuitive example, and that is the concept that we introduced at the beginning of this course, talking about firewall ACLs, right? Because access control list, the rules that are in that list, the order matters, right? So we're going to go over those 2 examples. And I'm going to start typing up at the top of this program just for giggles, right? We're not worried about how this looks, right? We're not doing best practices per se, as we're just getting used to these concepts. So I'm adding the 2 comments here just for instructional purposes. What is a set? What is a list? Both of these are ways to hold groups of things, okay? It doesn't matter what the type is. It could be a group of strings. It could be a group of ints. It is just a grouping of things, because again, we talked about how up to this point we've only been storing 1 data value, and now I want to talk about, hey, how do we hold and organize multiple values? Because honestly, that's going to happen a lot in your scripts. In my opinion, there's one main difference between using a set or a list to hold a group of things. And there's also a syntax difference, right? There's a difference in how you write it in the program so that the developer environment knows which data structure you're trying to use. Because these data structures are built into Python. A lot of what we covered up until now in this course has been built into the language, right? We reuse things all the time that are already there, because why reinvent the wheel? Coding data structures from scratch is something that computer science students will do a lot of times in foundational courses, and it's a pain in the butt. And it's just like for learning purposes. You don't need that crap. So anyway, the difference between the set and the list is that the set, the order doesn't matter, right? It doesn't matter. And the list, it does. So that's it. That's really it. So We've got two examples here, right? We've got our access control list, right, where I want to hold all of the firewall rules for a particular firewall. For Firewall West, I believe, is the one in our video. And then I also want to hold a group of switches so that I can add day switch uptime. Now, which of these do you think would work best as a set, and which do you think would work best as a list? All right, you probably guessed it right because you guys are smart. If you didn't guess it right, it's fine. You're still smart. So the switches, it's not going to matter how those are grouped, right? It doesn't matter if switch 1, 2, 3, 5, 7, 50 is in order or not, because we just care about the day's uptime. Adding is adding, right? There could be times when the order of switches matters, maybe. I can't think of an example off the top of my head right now, but maybe you can and can put it in the comments. However, when it comes to access control rules, 100% the order of these rules matter. Very likely anything that you're doing with an ACL involves the practical application of those rules, and and how those are applied will depend again on their order. So again, there could be a time where maybe you just need all of the rules just for like giggles. Like, I don't know, maybe you're evaluating how many rules contain a geolocation, or how many rules pertain to the DMZ. Then maybe you could put it in a set because the order of them doesn't matter and you're just kind of searching for key terms or things in those rules. But again, it's more intuitively a list where order matters. So let's start with our set. So for the set, so here's the thing, even though up to this point our variables have held only one thing at a time, they're still basically holding one thing by holding a data structure. And the data structure is, again, like the organizational system. So we need a variable to hold our data structures. Nothing is remembered in your program without a variable. The variable is how you call on things and how the program knows what to remember. I'm just gonna, for simplicity's sake, call this switches set. I could just call it switches. I like being ultra descriptive in my program, and again, it depends on what you're writing, who you're writing it for, whatever, on whether or not you've named it appropriately. But we're gonna name it switches set. And here's what I think the really nice thing is about creating a set versus creating a list is the difference. There's not much of a difference at all. And again, this course is about leveraging AI. We're going to start that in just a few videos. And what's great is if you don't remember the difference in setting up a set versus a list, we can just have AI remind us. We'll get to that later. But again, we're talking about learning problem solving skills, and then we bring in AI for like the memorization of random crap. But to create a set, we've got the variable, we've got the equals to say what it's about to refer to. And then we indicate that it's going to be a set by using the curly brace. That's it. Just by using the curly brace, Python is going to treat this as a set. Let's just put like switch 3, switch 5, switch 1, right? I'm doing this out of order on purpose just to show you it doesn't matter. And I'm not naming them because this isn't made up. Switch 500, switch 2. Now notice that there's squiggly lines underneath each of them. And it says switch 1 is not defined. So what's the problem here? Python has no idea what type of data this is. This is just like a random word, like plain English I've written into the developer environment. So we need to know what switch 5 is. For simplicity's sake, again, we're going to treat these as strings. So we need to let Python know that that's what this is. We can use double quotes, we can use single quotes. This switches set, we'll just basically make a set or group of switch names. All right, now no errors, beautiful. Now let's do our list, and we're gonna make up access control rules. And by that, I just mean we're gonna be just as lazy as we did just now, because it doesn't matter. We just trying to learn the concepts, right? So we're gonna do, for naming's sake, I feel like ACL list is a little bit confusing because it's access control list. These are the hard-hitting questions that you guys can ask yourselves as you become coding experts. So we're gonna name it ACL list just to match what we've done above. And instead of the curly brace, we are going to use the bracket. That's it. Python now knows it's going to be a list. And this time the order does matter. So, and remember, we have to put it in quotes because these are names of rules, which we're going to make strings because it's text. ACL rule 1. ACL rule 2, ACL rule 3. I'll add one more for giggles. So those are very crude, simple ACL rule. And again, I made the order matter in that one because it does matter, and it doesn't matter with a set. One thing to keep in mind too is that, at least in Python, you can have a group, like a set or a list of things of different types. Like you could have a number and a name and whatever, some sort of other object. Personally, I have never written a program where I mixed types of data in the same group because to me that seems confusing, but there could be scenarios where you do that. Like maybe you have a set of like all the information related to a single switch and you do that for each switch. I recommend starting out like with all of the same data type and get comfortable with it that way before you get fancy. So this is how you make the set and how you make the list. And let's go ahead and talk really quick about the dictionary before we ask some more advanced questions here. What is a dictionary? So this one is slightly different but highly useful in network engineering because this is whenever you want to have a group of items that has two things together, okay? It's called a dictionary because in the dictionary, when you, like a physical dictionary, when you look something up, there's a word and then there's a definition. They go together, right? In programming, it's called a key value pair. But examples of where you might want to keep two pieces of information together are maybe you want a group of IP addresses and the MAC address is currently associated with them, or a group of usernames and the IP address is currently associated with them. And there's many examples that you could use, right? But it's highly useful. For this example, let's do the username IP address thing, and I'll just name it username to IP dictionary. And having IP capitalized like that is probably like not best Python practice, but just weird to put it lowercase. I'm keeping it this way. Username to IP dictionary. And here's the thing. This one's also going to use curly braces, but the way that Python or the way that your developer environment is going to know that it's not a set and it's actually a dictionary is because you are going to separate whatever those two things that are associated together with a colon. So let's do an example. Let's say that we're going to start with username first. Let's do username Katniss, and then we'll do a colon and then whatever it's associated with. So 192.178. I don't remember my IP addresses. So again, don't come at me. I haven't done this in a long time. I am here for the people. Oh wait, this is going to be a string too. We just talked about that. Wow, guys, you really should have reminded me. I was really wanting to do two different data types here, right? But you can put anything. Like maybe you want to associate Katniss with like a random number. You could put like 1 here. That's fine too, because it's recognized as an int. But for the example, we did username to IP address, so Bobby, Billy Bob, blah, 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 blah. I'm limited to 2 because I'm getting tired. So now we have 3 data types here, or 3 data structures here, right? Yay! You know some data structures, right? Anybody can know this stuff, and these are really useful, and hopefully you can see not as complicated as maybe what you've seen or heard about online. And now you can pass these structures into your functions just like we were doing earlier with other variables. But here's the question that you may have already caught on to at this point. How do we access the information in these data structures, right? Before, you just called a variable and it's only holding one thing, so, that's it. And there's certain things you can do with each data type. But when you have a group of data types, like how do you, for instance, pull the third item out of a list, or how do you work with multiple things in the set? So first of all, you could go read the online documentation for Python if you just want to know everything possible for what you can do with these data structures and how to work with them. But this is what I think from a practitioner standpoint is maybe more useful and less boring. And that is, and I need you to just run with this and just trust me on this being something you do in coding, because I'm not yet going to be able to explain the concept to you without confusing you. So because these are all built into Python, not only has Python, the language, already developed the syntax and rules related to a set, what is a list, what is a dictionary, but it's also associated with a number of other logical actions and basically features. It's called attributes, but whatever. And the way you access that, and again, I need you to just, for this video, go with it. I was not planning on going into object-oriented programming in the foundational course or in level 1 of this course, but thinking about it now, I probably just should. I'm sorry. I know that you guys don't love the theory, and I know we just want to build cool crap, but you gotta know the basics, I think. So let's say that I want to know what I can do with this set, because it's created by Python, right? We didn't code it from scratch, so therefore we don't know what we can do with it. What we're gonna do is type switches set. You can see it auto-populates when I start typing it, and I'm gonna hit tab to go ahead and not finish typing that. And then I'm gonna hit the period, and now you see all of these things that come up. So you don't have to remember this, I'm just doing it so you can like kind of know what's going on here. These purple boxes all mean, hey, this is a logical thing that you can do with this set. So you can add, clear, copy, difference, and again, you can read the documentation and whatever. Take the slow route, take the theory route before applying it. But again, that gets boring, and are you fully gonna remember it? I don't know. So you could just make some assumptions and play around with the logic here and see what happens. So I'm gonna give you an example. Let's say, let's try starting with add, right? Because that one seems important. All right, so let's do add. And then because it is a piece of logic, because it is a function, what happens, what do you need in order to call a function, guys? Remember, we've done this with our own functions we've written, but we have not done it as much with built-in Python functions. What do we do to call it? We do the name of the function and then the parentheses and anything that has to go in between the parentheses. Same thing happens here. So when I start this parentheses, now all of a sudden we get more information about what this function is doing and what is required. So it adds an element to a set. Perfect, right? So this is what we would use if we want to add another switch to our switches set. And note that it says this has no effect if the element is already present, right? So you don't have to, again, go into documentation. It's all right here in your developer environment. So let's test it out. Let's try adding switch 5000. Beautiful. So now, how do we know if it works? Any ideas? We're going to do what we've been doing. So first of all, to know what we're doing right now, we've been printing it to the terminal. That's how we've kind of been seeing what's going on behind the scenes with our code. So we're going to print this, but again, we need to know what to print. Based on what we've learned so far, in order to print this, we really need to put this in a variable, right? Because again, we're adding this switch to a switch set, and that's going to work. That's functionally going to work, but your program is not going to remember exactly what happened as a result of this line unless we store it in a variable. Let's do a variable right here. Let's just call it added switch. Boom. So now whatever happens in switches set.add is going to be stored or remembered in the added switch variable. And we're going to print out that added switch variable so that we can see what is happening. So let's try it. Oh, it printed none. Oh, wait, actually, I did not think about that. Excuse my pregnancy brain. So we don't, oh my God. So we don't want to print the result of the add because, I mean, there's nothing to see. Ignore that. Let's, we want to print what switches set now looks like. Now, what do you think is going to print to the terminal when we print switches set? Is it going to look exactly as it does on line 2? Or is it going to have the additional set or switch in it? Let's find out. All right, so we see switch 5, switch 1, switch 5000, switch 2, switch 3, switch 500. So switch 5000, our added switch, is in switches set now. You'll notice that it's in there kind of randomly, right? Because the order doesn't matter with a set. So for some reason, it's in there as number 3. Why did it show up here when switches set is not currently holding that, right? We've added it down here, but like, what's actually happening? Well, again, Python is running line by line. So we've defined at the top of the program what switches set is, and then we're doing things to that set throughout the program. And those things are what are going to be executed or performed before we actually print what switches set looks like. All right, so here are some of the trade-offs that I make during this course, guys. And that is that it is very easy to get bogged down in theory and boring crap and things you're not gonna remember when doing tutorials and courses. And here's the thing. Logically, or let's put on our, our thinking cap, I have just unlocked 3 different types of data structures that you can use. What each are used for in general, right? Now, and I've also told you how you can access the logic that is associated with them, right? So we call the name of our variable holding that data structure, then we do the dot, and then that shows us all the Python things we can do with that type of data structure. Now it is your job to do 2 things, and we're also going to practice this together in future videos because we're building. I need you to practice thinking. When you're thinking of an automation or scripting problem or coding problem, out of the tools I know so far, what would apply here? What would make the most sense and why? Start thinking through that. That's how you're going to develop some of that programmatic thinking that we talked about. It's also now your responsibility to actually physically play with the logic associated with each data structure. Again, I could sit here one by one and show you all different things you can do with each one. But let's be honest, that would be really boring. That'd make a really long video. And also, are we really going to remember that? I think that even as developers, right, we kind of find things as we need to find them, right? We don't just have everything memorized for everything. Especially if you're not always doing the same types of tasks or working in the same language. You'll notice that, for instance, if I use a dot after our dictionary, right? You'll notice that some of the logic looks the same. Like, I think we saw clear for our set. I remember we also saw pop. But you'll also notice that there's no add, right? So the logical things you can do with each data structure is different. And it's up to you now to create your own dictionary or list or set and play around with what is possible. What can you do with each of these built-in structures so that you know how to apply them to problems you want to solve? Now, again, I'm doing it the way I'm doing it for a reason. So we will continue to build on this example in our future videos rather than beat a dead horse. But if you have any questions or comments, feedback, let me know in the comments. And as always, practice, and I'll see you in the next video. Take care.